All right, imagine this. You're sitting on a train, looking out the window. The train starts moving, slow at first, then faster. You throw a ball straight up. To you, it goes up and down, easy. But to someone standing outside, the ball traces a weird arc because the train is moving. So, whose perspective is right? Both. That's the magic of relativity. And today I want to blow your mind with Einstein's special theory of relativity. First, let's rewind to the late 1800s. Scientists thought light, like sound, needed something to travel through, an invisible ether. But in 1887, the famous Michelson-Morley experiment tried to detect this ether and found nothing. Light didn't care how fast you moved. It always zipped along at the same speed, about 300,000 kilometers per second. That's when things got weird. Enter Einstein. In 1905, he said, "Hey, what if the speed of light is the same for everyone, no matter how fast you're moving?" Sounds simple, but this idea flips everything you know about space and time on its head. Let's say you're on that train again, shining a flashlight forward. You'd think the light beam moves at the speed of light plus the train's speed, right? Nope. Whether you're sitting still or racing at half the speed of light, the light always moves away from you at the same speed. That means space and time themselves have to flex and bend to keep light's speed constant. Here's where it gets wild. If you move faster, time actually slows down for you. This is called time dilation. Astronauts on the International Space Station age just a tiny bit slower than people on Earth because they're moving so fast. People on Earth. And if you could somehow travel close to the speed of light, you'd barely age at all compared to your friends back home. But wait, there's more. Length contraction means objects shrink in the direction they're moving, as seen by an outside observer. And most famously, E equals mixed squared energy and mass are two sides of the same cosmic coin. So what does this all mean? The universe isn't as rigid as it seems. Space and time are part of a flexible fabric, stretching and twisting depending on how you move. The faster you go, the weirder things get. Einstein's special relativity isn't just theory. It's built into GPS satellites, particle accelerators, and the very fabric of modern physics. The next time you look at a clock or gaze at the stars, remember, time and space are stranger than fiction. And that's the mind-blowing magic of special relativity. Thanks for watching.